Hello, Advanced Algebra students. I am super happy to be teaching you again today. We are starting off Chapter 2, and the first section of Chapter 2, 2.1, has two pieces, 2.1a and 2.1b. 2.1a is a mini review of slope. So at the top of your notes, go ahead and put 2.1a, slope and rate of change. Rate of change is just another way of saying slope. So the formula for slope is m equals y2 minus y1 over x2 minus x1. So that is a super important formula for you to have, and we'll be using it throughout the rest of these notes. And again, I'm just going to do a streamlined version of these, but let's do an example where it says, find the slope of the line passing through the points, and let's call this example 1, 1, 2, and 4, 4. So in this kind of a case where we have been given an ordered pair and a graph, as it is on the notes here, oftentimes it's easier just to count out the slope. So I'm going to show the point 1, 2, and I'm also going to show the point 4, 4. And if you have graph paper, of course, that might make it a little bit easier for you to graph. But if you don't, then you should be totally fine just doing your best job to do it on the paper that you have. Okay, now the cool thing about slope is that we can count it out starting at either point. So let's say, for example, that we start at the point 1, 2. Since slope means rise over run, we're going to count up 2, and then we're going to count over 1, 2, 3. So we're going to get a slope of 2/3. Now I still remember when I first relearned math, 15 years ago or something like that. It had been a while since I had taken math. I had forgotten the fact that it didn't matter if you counted from either point. It was hard to believe that it actually worked, but here's how it does work. If we start at the 4, 4, rise in this case would mean going down, so we would go down 2. So let me use a blue marker here. We could go down 2, which would be minus 2, and then back 3, which would be minus 3. So that would be like saying negative 2 over negative 3, which cancels out to be positive 2/3 again. So we're going to end up with the same slope regardless of what point we start at. Now, typically, when you have a slope problem in advanced algebra, you will not be provided with a graph. So let's just do one where we use the formula, and this will be example 2, and the points are going to be negative 3, 6, and negative 7, 3. So the way that I label these is I put an XY underneath the first point and an XY underneath the second point, and then I put 1s on the first point and 2s on the second point. And then I simply plug everything into the formula given. Now, it is super important to remember to do the y's on top. So we're going to do 3 minus 6 on the top, and then negative 7 minus negative 3 on the bottom. These two minus signs cancel out, and then this becomes negative 3 over negative 4, and again the negatives cancel and the slope is just 3/4. So that would be an example of just using the slope formula. Now, both of the slopes we just found were positive numbers, but that will not always be the case. So for example 3, let's talk about the 4 types of slope. 4 types of slope. So one type is when your line is going uphill, and that is going to be positive slope. That's what we just had. We had positive 2/3 and positive 3/4. Another possibility, obviously, is if your line is going downhill, then you have negative slope. So that would be, for instance, if we got negative 2 or negative 3.5. Now there are 2 other possibilities. Do you know what they are? Instead of being positive or negative, what are the 2 other possibilities for slope? One of them would be 0 slope. Now, for zero slope, you are going to have a horizontal line. And the way I remember that is a capital Z has two horizontal lines in it. So that would be zero slope, just a flat horizontal line. The other possibility is no slope. So a line with no slope is a vertical line. And the way I remember that is that the word no, for no slope, the letter N has two vertical lines in it. Okay, so we've talked about the slope formula, how to count it out, how to use the formula, the four types of slope. Let's do some calculations where we would actually encounter either no slope or zero slope and see what the math would look like when you get to that point. So I believe we are now on example 5. The directions they have on the paper, and you do not have to write these down, are find the slope of the line that passes through the given points, then tell whether the line rises, falls, is horizontal or vertical. So I'm just going to do 2 examples. Example 5 would be the line going through the point -5, 1 and the point 3, 1. Now again, you could choose to plot these on a graph, but generally, if we're doing a bunch of slope problems, we just use the slope formula because it will typically be faster. So we can, if we want, label these with an X and a Y, put 1s on the first point and 2s on the second point. Then when I do the calculations, I'm going to get 1 minus 1 over 3 minus -5, or 0 over 8. Now, some students get mixed up when the answer is 0 and when it's undefined. An old math teacher friend of mine used to say 0 on the top is okay, 0 on the bottom, no way. So 0 on the top just means any 0 divided by any number is just 0. So this would be an example of a line with 0 slope. It's okay to have 0 on the top. It's not okay to have 0 on the bottom. So 0 on the top just means the answer to our problem is 0. Now, for example number 6, if we look at the point 4, 6 and the point 4, -1, again, we can label these with an X and a Y, put 1s on the first point and 2s on the second point. Then, when we calculate slope, we're going to have -1 minus 6 over 4 minus 4, or -7 over 0. Now that's where we encounter a problem because it is not okay to divide by 0. So in this case, what we're going to have to say is it equals no slope, or we can say undefined. Either way, we cannot leave our answer as -7 over 0. We have to write it as either no slope or undefined. Okay, now I wanted to tell you guys something about parallel lines and perpendicular lines. Can you remember how the slopes of parallel lines compare and how the slopes of perpendicular lines compare? All right, so parallel lines, let's just write this here. Parallel lines have the same slope. And then perpendicular lines have what we call opposite reciprocal slope. Opposite reciprocal. So let's do an example of the perpendicular lines. Let's say our first line has a slope of 2/3. What would be the opposite reciprocal of 2/3? It would be -3/2. Let's say that our first line had a slope of -1/2. What would be the slope of the line perpendicular to that line? What would be the opposite reciprocal of -1/2? The opposite reciprocal would be positive 2/1, or you could just write it as 2. Okay, I think that that's all that we need for slope. I hope that you have a good day, and I can't wait to see you in Zoom. Okay, bye.